1.6. 1.6 objectives. Solve polynomial equations by factoring. Solve radical equations. Solve equations with rational exponents. Solve equations that are in quadratic in form. Solve equations involving absolute value. Solve problems modeled by equations. Do you see a common theme running through today's objectives? Solving, right? Solving. Okay. So let's start with solving by factoring. You okay with that? We dealt with a lot with factoring in section 1.5. Okay. So let's talk about a problem like this. 2x to the 5th plus 10x to the 4th equals 0. Okay. So you know you're solving because it's equals 0 or equals something, right? It's an equation, so we've got to solve it. So how do you want to try to solve this equation first? Greatest common factor. Okay, what's the greatest common factor between these two terms? They're both divisible by 2 and x to the 4th. That's exactly right. Okay. If I factor out a 2x to the 4th from each term, what do I have left? X plus 5. If these two things multiply together and equal 0, what has to be true about at least one of them? One of them equals 0, right? So we say 2x to the 4th equals 0 and x plus 5 equals 0. Well, if I need to say x to the 4th equals 0 like that, I can, but what does x equal in this problem? 0, right? Okay. What about the right side? X equals negative 5. Any questions about that one? Do you remember how we'd go about solving this equation? Yeah, there's 4 terms, right? If there's 4 terms, we want to try to group them. And we actually called it solving by grouping, right? We solved, just look at the first two. What's the greatest common factor in the first two? X squared. What's left if I divide an x squared of just the first two terms? X plus 1, right? What's left, or what's common in just the second two terms? 5. What's left if I factor an x plus 1? What's my goal? To have the same parentheses right here. Remember that? Because if I have the same parentheses right here, looking at these two terms, 1, 2 terms, what do they have in common? An x plus 1, right? What's left if I factor out an x plus 1? X squared plus 5. That's right. If these two multiply together to equal 0, what has to be true about at least one of them? So x plus 1 equals 0, and x squared plus 5 equals 0. Subtracting 1 from both sides gives me x equals negative 1. Subtracting 5 from both sides gives me x squared equals negative 5, but I'm not done yet, am I? What am I trying to solve for? X, okay? So if I take the square root of both sides here, what do I get? Plus or minus I square roots of 5. That's right. Okay, I square roots of 5 because the square root of 1 is I. I bring it out. I don't know the square root of 5, so I leave it. Okay? Questions? How do you feel about solving by factoring? It's basically all the stuff from 1.5, all the factoring that was involved, and now we're just solving it by factoring. Okay? So what about this? What's next? Oh, radical equations. Yes. So what about this equation? 2x minus 1 plus 2 equals x. How do you want to solve this equation? How do you want to solve an equation if there's a radical in it? I eventually want to square it, but before I can square it, I need to isolate it, right? Okay? So if I subtract 2 from both sides, won't that isolate that radical right there? Because it'll just be square root of 2x minus 1 equals x minus 2. Okay? Now what do I want to do? Square both sides, right? Keep in mind that I'm squaring both sides, right? What do I get on the left-hand side? 2x minus 1. What happens on the right-hand side? I square the whole thing, right? So I just get x squared minus 4. I'm so glad you argued with me. That just made my day. X minus 2 squared means x minus 2 times x minus 2, right? I have to distribute. I do get x squared, but I also get minus 2x, which is minus 4x, and then I get negative 2 times negative 2, which is plus 4. If you don't distribute, you will always miss this middle term, and you will get the problem wrong. I don't want you to do that. Okay? Now what? Now I just have a polynomial, more specifically in this case, just a quadratic, right? And I just have to solve it. In order to solve it, I want to get it equal to 0. So I'm going to subtract 2x from both sides. And I want to add 1 to both sides. When I do that, I get 0 equals x squared minus 6x plus 5. How many different ways do you know how to solve this quadratic? I think 5, right? I think 5. Which way would you like to choose? Factoring? Okay, so what AC is 5, B is negative 6. What multiplies to be 5 and adds to be negative 6? Negative 5 and negative 1. Excellent. And if that equals 0, what do I have to do with each factor? Set it equal to 0. X minus 5 equals 0. X minus 1 equals 0. Add 5. X equals 5. Add 1. X equals 1. So I've done a really bad job in the last two examples, because once we got the answers, we just went on, right? What should we have done? Checked them. Okay. Does it really make that much of a difference? Well, let's see. 2 times 5. 10 minus 1. 9. What's the square root of 9? 3 plus 2. Does that equal 5? Do 5 equal 5? Yeah, we're good. This is a good answer. 1. 2 times 1. 2 minus 1. The square root of 1. 1 plus 2. Does 3 equal 1? No. Do you remember what this answer is called? It's an extraneous solution. It's an extra solution that we got, but it doesn't work, right? Questions? Okay. How do you feel about radical equations? Could you solve a radical equation if I ask you to? Then let's talk about one with rational exponents. Okay? Rational exponents. So 3x to the 3/4 power minus 6 equals 0. So if we're talking about this type of problem, what are we going to do first to solve for x? What did you say? Subtract 6? Yeah, that's perfect. I mean, add 6? 3x raised to the 3/4 power equals 6. Now what? We're just trying to isolate the x, right? So what do we do now? Divide by 3 on both sides. X to the 3/4 power equals 2. I don't know if you remember making this last year. Do you remember making this? On the back page, we talked about how if a has a fractional exponent, it's the numerator is the power, the denominator is the root, right? Okay, the numerator is the power, denominator is the root. So keep that in mind. How do we get rid of a fractional exponent? I need that exponent to be what? I just need it to be 1, right? What can I multiply 3/4 by to make it become 1? 4/3. Well, if I raise that side to the 4/3 power, what else do I also have to do? I have to raise the other side to the 4/3 power as well. Okay? Remember power of power properties? Power of power, I multiply those numbers, right? We did that on purpose here. Because if I multiply that across, that's 12 over 12, which is just 1. So I just get x to the first, or just x. And here I have 2 raised to the 4/3 power. Okay? I need to show you 2 other answers that are equivalent to this, because this is one of those situations where I don't know what the computer will want. Okay? I need you to realize this equals this, because of what we just talked about. The numerator is the power, the denominator is the root. So I just wrote it as a radical with a cube root, and it's 2 to the 4th. But I also want you to know that this is the same as this, because 2 to the 4th is 16, right? That's something we could easily simplify. So if it wants anything, it's probably not going to want this. It probably wants either this or this, because this can be simplified. Does that make sense? Okay so far? Okay, let's do another one of those with rational exponents. X to the 2/3 power minus 3/4 equals negative 1/2. Now, a lot of people would just balk at this whole problem because there's too many fractions in it. Not you. Not you. What do we want to do first? Add 3/4. If I add 3/4 to both sides, isn't this the same as 2/4? Good. So I have a negative 2/4 and a positive 3/4. What does that give me? 1/4. Okay. What happens on the left-hand side? Just x to the 2/3, right? Well, what do I do? So I raise it to the power of 3 over 2. That's exactly right. Okay, raise it to the power. I'm multiplying the power by 3 over 2. Because on the left-hand side, that gives me an x. And on the right-hand side, all right, let's think about this for a second. I have 1/4 raised to the 3 over 2 power. And remember, the top is the power, and the bottom is the root. So it's saying, what is the square root of 1/4? Well, it was a 2 before, right? So we didn't even worry about it because that's not anything that we know root of or anything. Well, except I know the square root of 1/4, don't I? What is it? 1/2. Yeah, that's right, 1/2. Now, what's 1/2 to the 3rd power? Remember, when we're raising a fraction to a power, we raise the numerator to that power and the denominator to the power. So 1 over 8. So x equals 1 over 8. Except we just have to be careful, right? What kind of root did we take? A square root. And so what has to go in front of the 1/8? Yep. Because when we take a square root, we could get the plus or the minus, right? The positive or the negative. It doesn't look like a square root, like the thing, right? But it still is taking a square root because I have to the 1/2 power, right? So we just have to be careful of that. How are you feeling about equations with rational exponents? Good? Okay. So let me ask you this. Could you solve this equation right here? X squared minus x minus 9 equals 0. Could you solve that? That's super easy to solve with factoring, isn't it? But that's not the equation we're doing. We're doing this equation. X to the 4th minus 8x squared minus 9 equals 0. Doesn't that look a whole lot like that one? Do you feel like if you could do this one, then you could also do this one? You should be able to, right? So here's the deal. There's a thing that they do in college algebra. We never did it in Algebra 2. It wasn't in our TEKS. It wasn't required. Okay? They do something called a U substitution. Where they make this problem right here look like this problem right here. Because we can solve that one. We're confident in solving that one, right? So what they say from the very beginning is x squared equals u. Well, why would we make x squared equal u? What does this become then? If x squared equals u, this now is u squared. That's exactly right. Okay? Minus 8 times u minus 9. Well, guys, how are these two different? They're not. You know how to solve this one, don't you? Well, solve it then. What do you get? I'm going to write it over here. I'm going to go this way. I get u minus 9 and u plus 1. Right? Well, u minus 9 equals 0 and u plus 1 equals 0. So u equals 9 and u equals negative 1, right? What do you think? What does u equal? U equals x squared. So once I have u solved for, I have to go back up here to this u substitution definition that we made up. And I have to say x squared equals 9. And x squared equals negative 1. Well, if x squared equals 9, that's super easy to solve, isn't it? Square root both sides, what does x equal? Or plus or minus 3, right? And if I take the square root of both sides here, what do I get? Plus or minus I, right? Is that hard? No, what's the hardest part of that whole problem? Usually it's figuring out what u should equal. Okay? This seems pretty obvious because I could do something that's at x and it just said x squared right here. So what if I made x squared equal to u? Well, then this looks just like u squared. It just make the whole equation just look exactly like the one we already knew how to solve, right? So look for something that makes it familiar. Look, this is not a quadratic because it's to the 4th power. Look for something to substitute that makes it a quadratic. Okay? We want to take, if at all possible, we want to, these are called equations that are in quadratic form because they're not quadratics, but look at the exponent here, a 2 and a 1. Look at the exponent here, 4 and a 2. How does this exponent relate to the first one? It's half, isn't it? 1 is half of 2. 2 is half of 4. Could this be a 6? Yeah, if this was a 3, right? Then we would use u would equal x to the 3rd. Because this would still be u squared. See what I'm saying? Now, we could have gotten to this pinkish purple one up here. We could have said, oh yeah, I know how to solve that. That's just x squared plus 9, or minus 9 and x squared plus 1. Right? If I came down here, I could have said that's x squared minus 9 and x squared plus 1. Because we did talk about ones that were a little bit more difficult like that in Algebra 2. Okay, where we said x squared minus 9 equals 0 and x squared plus 1 equals 0. Where we get x squared equals 9. So x equals plus or minus 3. X squared equals negative 1. So x equals plus or minus I. We get the same thing. It's a little cleaner over here this way with the u substitution though. Okay? Any questions about that? So are you okay with u substitutions? Maybe? A little bit, perhaps? What about solving equations involving absolute value? It's actually what we're doing in Algebra 2 right now. So that means it's been a while since you've seen it because it's right at the beginning of the year. So do you mind if I remind you a little bit? What we said is that the number inside of the absolute value is allowed to be positive, so it's allowed to be exactly what it is, or the number inside is allowed to be negative. Just like that. Okay? Now, I'm telling you right now, a lot of people change this number, make it a positive or negative, and with equations, it doesn't matter. If we ever get to inequalities, it so matters. Okay? So I just always say what's inside is positive, what's inside is negative. So then I don't get confused. Okay? So I just have two parts. I have two parts of the equation. So in this case, I get x equals 3. Here I go ahead and I could either distribute or I could divide both sides by a negative 1. Each way or either way will get me to the same place. 2x minus 1 equals negative 5. If I add 1 to both sides, I get 2x equals negative 4. So x equals negative 2. Okay? And remember, part of the rule about solving absolute value equations is that we also show graphically what that means. If I've got negative 2 over here, then I got 3 over here, and I've got a point on the number line for each. Does that make sense? Okay. One more example. Absolute value of x plus 5 equals negative 4. When will the absolute value of any number equal a negative? When will the absolute value of any number ever equal a negative? Never. Absolute value is the distance from 0, right? Distances are negative or positive? Positive, right? Anytime we take the absolute value of number, we get a positive number. This is positive. When is a positive number going to equal a negative number? It never will, so we have no solution. Okay? Solve problems by modeled by equations. What does that mean? It's our favorite one. Word problems. Okay? So it's probably going to be all of these things up here, but just word problems of those equations. Okay? Got it? How do you feel about these objectives today? How confident are you feeling? Pretty good? Medium? Confident? All right. Awesome.